Today we're talking about reasoning in algebra and geometry. We're going to be introduced to proofs, and I'm just going to warn you now, you probably are not going to like them. But the more you practice, the better it becomes. And the fact if you know your definitions, you might find this easy. First of all, you should have these written in your notebook and just give an example of each one. So addition property, you can add a number on each side of the equation. Subtraction property, you can subtract the same number on both sides. Multiplication property, multiply on both sides. Division property. Now, if you already know these properties, you don't have to write this down. But these are going to be the why part, or the then part, when we have algebraic proofs. These you should write down. You need to write these down because these are properties that you do not know off the top of your head. So in a proof, sometimes we might have to state that something is equal to itself. So if we ever do that, the y would be reflexive property. Or symmetric property, a equals b, then b equals a. Make sure to write that down, symmetric property. Intransitive property is kind of like the law of syllogism, where if a equals b, b equals c, then a has to equal c. And substitution property is if we know that something's equal, we can just replace that in the equation. And the last property that you should have written down before we actually look at a proof is the distributive property, which you've already done, but you have to know what it means. And that just means it's being multiplied and be used for both addition and subtraction inside the parentheses. So now this is going to be your first proof, and we have to justify each step. Okay? So my first statement says angle AOM and MOC are supplementary. And I have to say my why, my reason. For this, we could say that they're a linear pair. Linear pair. Now I want my next step. When you're solving for your next step of your statement, you always want to look at the previous statement to help you. So I already said something about angle AOM plus angle MOC, and supplementary means 180. And my reason for that could be definition of supplementary angles. Now my overall goal is to find out what x is. So now what I'm going to do is substitute in what I know. I know angle AOM is 2x plus 30. And I know angle MOC is x. And that's going to be equal to 180. The reason I can do that is by substitution. So now looking at my previous statement, I'm going to combine my like terms and get 3x plus 30 is equal to 180. Now in the book it would be the distributive property, but I'm just going to write combine like terms. I would accept either answer. Now my fifth step, I'm going to write this as 3x is equal to 150. And what I did there is I subtracted 30 from each side. So that would be the subtraction property of equality. And then my next step would be x is equal to 50. And how I got there would be division property of equality. Once you get to the step that you have the answer for, so I was looking for x and I found x, then you're done. You don't have to write done. Once you see your objective or your proof statement, you are done. So here's another proof. So typically we'll have a given statement. It did not pop in, so I had to write it in myself. But that will always be your first thing written in your statement column, because you'll have statements and you'll have reasons. So the reason I can say that AB bisects, this should have a line above it, angle RAN, is I just write given. Will always be the case. I would say this would be the easiest step. And like I said before, you should always use what was talked about before to help you write out the next statement. So if I know it bisects that, I can write that x is equal to 2x minus 75. And the reason I know that is because once I know something bisects, I know you have two congruent angles. So this would just be definition of angle bisector. And then my next step here, again, I'm trying to get x by itself, would be a negative x is equal to negative 75. And what I did there was I subtracted 2x from both sides. If you want to write that step, you can. You do not have to. So since I subtracted from both sides, this would be subtraction property of equality. I just like to shorten it up so I don't have to write as much. And then my fourth step would be x is equal to 75. And what I did was divide by -1. So my reason here would be division prop of equality. We are going to be getting into a lot more proofs within shapes, so you will have to know all of these different properties. Make sure to write this down. You can use this information on quizzes. Make sure to write this information down. So reflexive property is basically saying anything is congruent to itself. So symmetric property is saying that if AB is congruent to CD, then it doesn't matter the order that you write it. And transitive property is, again, like the law of syllogism. If AB is congruent to CD and CD is congruent to EF, then AB and EF also have to be congruent. So the difference between these and the properties that were stated at the beginning are just that these are congruent and the other statements were equal. So this problem says, which property is being used? Well, first, in this first problem, I have an equal sign, so I know it's going to be a property of equality. And the difference between the first statement to the second statement is I don't have a 9 there anymore. How did I get rid of that 9? I had to subtract from both sides, so this would be subtraction property of equality. Again, you need that in equal sign at the end. Number 2 has a congruent sign, so I know it's going to be a congruent property. And it's saying from if O is congruent to W, W is congruent to L, O is congruent to L, this would be my transitive property of congruence. So instead of writing equal sign, I have to write congruence. And the last one, if measure of angle E is equal to measure of angle T, and I can switch both of those over, this would be my symmetric property, and I have an equal signs would be property of equality. So now we're actually getting into proofs. Proof is convincing of an argument that uses deductive reasoning. So basically using facts that we know. A 2-column proof lists statements and the justification. We typically will set it up with statements on the left, statements, and then your reason or your justifications on the right. This is how any two-problem proof will be written. When we see a proof like so, the given should always be your first step, and the proof, that should be your last step in your statements column. Again, you have your statements and you have your reasoning. So I'm first going to write down measure of angle 1 is equal to measure of angle 3. And my reasoning behind that is because that was given. This will always be the easiest step. Now if I look at my picture, that would be angle 1 and angle 3. And then you should always look, what am I trying to get at? I'm trying to see that angle EAC, this angle right here, is going to be equal to DEB. So when I trace out both those angles, I see that they kind of overlap at angle 2. So I have to, before I can just assume anything, I have to make a statement. So I'm going to say measure of angle 2 is equal to measure of angle 2. And the reason would be the reflexive prop of equality. When I look at this picture, I see that in order to say those are congruent, I have to first add angle 1 and angle 2, because my larger angles have two parts to them. So what I'm going to do is just add my first two statements and say that measure of angle 1 plus measure of angle 2 is going to be equal to measure of angle 3 plus measure of angle 2. And all I did again was add the first two statements. The reason I can say that would be the addition prop of equality, because I just added those two together. My fourth step, I need to actually state what angle AEC is equal to and DEB, because that's what I'm trying to get to. So I'm going to say that measure of angle AEC is equal to measure of angle 1 plus measure of angle 2. In the same statement, I'm going to write measure of angle DEB is equal to measure of angle 2 and measure of angle 3. And the reason I can say that is because the angle addition postulate, saying that one angle, one large angle, is the addition of any two smaller angles that it makes up. So like an example would be this angle right there. Now I can actually say my proof statement. Measure of angle AEC is equal to measure of angle DEB. And the reason I can say that is through substitution. Because if I look what I have above, I have already that measure of angle 1 equals measure of angle 2. And I stated that here. I also have measure of angle 3 plus measure of angle 2 is equal to my DEB. So since I already stated that these two are congruent, then I know the actual angles themselves are congruent. And as you watch this, you might have thought this doesn't make any sense whatsoever. We will be practicing this a lot, so relax. And trust me when I say I will help you through it. I understand that proofs can be very difficult, but that's why we practice over and over again. Make sure to fill out the Google Doc form and submit your answers. Thank you. Have a great evening.